Hello everyone and welcome to another episode on this very channel. In today's tutorials, we'll be looking at listing the sample space for a compound experiment. This is what we'll be looking at in this very lesson. If you have not subscribed to my channel, please kind of hit on the subscribe button to get notification whenever I upload a new video on this very channel. Let's get started. Now, what is sample space? As we have already discussed in our previous lesson, when we talk about sample space, it refers to all the set of possible outcomes in a given experiment. And when we talk about an experiment, it is an operation whose outcome cannot be predicted with certainty. Example of an experiment is flipping of a coin. So this becomes an experiment because the outcome of this cannot be predicted with certainty. So when we are able to list all the set of possible outcomes for this experiment, then it becomes the sample space. And we know that when we toss or flip a coin, we are either going to get a head or a tail. So the set of possible outcomes, which is the same as the sample space, is what we are talking about here. The head and the tail become the sample space for flipping of a coin. Another example of an experiment is throwing of a die. So we have experiment. Throwing of a die also becomes an experiment because the outcome of this cannot be predicted with certainty. We know that when we throw a die, we are either going to have a phase 1, phase 2, 3, 4, 5, or 6. So all these set of possible outcomes become the sample space for the throwing of a die. So we are going to have either 1, 2, 3, 4, 5, and then 6. We are saying that this is an experiment because when we throw the die, we cannot predict with certainty, or we cannot say for sure or 100% sure that this die that I'm going to throw, I am going to get the number 6. So the throwing of a die becomes an experiment, and then flipping of a coin also becomes an experiment. Now, what is a compound experiment? Now, when we combine these two experiments into a single experiment, then we can say that this experiment is a compound experiment. Another example of a compound experiment is a fair coin being tossed 3 times. You have a coin and then you are tossing it 3 times. It becomes a compound experiment. Another example of a compound experiment is tossing a coin twice. You have one coin and then you are tossing it 2 times. It becomes a compound experiment. How do we list the sample space for a compound experiment? So in doing that, we are going to look at these two examples on the board. Let's start with this. We have a fair coin is tossed twice. So we have tossing the coin twice. So we are going to have the first toss and then we are also going to have the second toss. How do we list the sample space for tossing this coin 2 times? Remember that tossing a coin 2 times is the same as tossing 2 coins at the same time. Tossing a coin twice is the same as tossing 2 coins at the same time. Kindly take note of it. So in listing the sample space for a tossing of a dice, we are going to use two approach, that is the table method and then the tree diagram. So we are going to draw a nice table to represent it. So we are saying that we are going to toss the coin 2 times. So we are going to use this column to represent the first toss. So we have the first toss, and then we are going to use this column to represent what? The second toss. We know that when we toss a coin, we are either going to have a head or a tail. So this column, we are going to write a set of possible outcomes when we toss a coin once. So we have the head and then the tail. So on this row, we are still going to have a head and then a tail. So we have a head and then a tail. So once we have this, we are going to pair the outcomes from the toss of the first coin with the outcome from the toss of the second coin. So we are going to pair the outcomes. So we are going to have head, head. So we have head, head. Let me use the black and red for you to see well. Head, head. And then we have head, tail. So we have head and then tail. Then move on to the tail. We have tail, head. And then we have tail, tail. So the outcomes in this arena become the sample space for this experiment. So therefore we can say that the sample space for this compound experiment is head, head. So we have head, 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 tail, tail, head, and then tail, tail. So these are the set of possible outcomes when a fair coin is tossed twice, which is the same as the sample space for this experiment. Let's look at the second method. With the second method, as I said earlier on, we are going to make use of the tree diagram. So we are going to draw this to represent the first toss. So we have the first toss. So when we toss a coin, we are either going to have a head or tail. We are tossing the coin 2 times. So this is the first toss. Let's look at the second toss. So when we toss it again, we are still going to have a head and then a tail. The same thing applies to the tail side. We have a head and then what? A tail. Now once we are done with this, let's see how we can read it. So in reading it, this is how we read it. We have head, head. So we have the sample space to be head, 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 tail. Now move on to the tail side. Tail, head, and then tail, tail. So it means that we can either use the table or the tree diagram to list the sample space for a coin being tossed twice. So this is the sample space for a coin being tossed twice using what? The tree diagram. Let's look at this example. So with the second example, we are saying that a fair coin is tossed 3 times. It's the same as tossing 3 coins simultaneously. So a coin is tossed 3 times. We want to write down the sample space or all the set of possible outcomes for this experiment. We can use the table or the tree diagram. So let's use the tree diagram, then after that we come back to the table. So we are saying that a coin is tossed 3 times. So on the first toss, this is the first toss, we are going to have what? A head and then a tail. On the second toss, we are going to have the head and then the tail. So this is the second toss. On the third toss, we are going to have a head and then a tail. So this is what the third toss. Because we are saying that a coin is tossed 3 times. So the first toss, the second toss, the third toss. So this side too, we are still going to have a head and then a tail. So we move on to the tail side. On the second toss, we are going to have what? A head and then a tail. On the third toss, we are going to have what? A head and then tail. On the third toss, we are going to have a head and then a tail. So let's look at how we can read this from the diagram. So we have head, head, head. You move up, head, head, head. So let me write it down. So we have the sample space, we have head, 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 comma. Then move on to head, head, tail. So we have head, head, tail, comma. Then move on to head, tail, head, head, tail, head. Then move on to head, tail, tail. So we have head, tail, tail. So we are done with the head side. Let's move on to the tail side. We have tail, head, head. So we have tail, head, head. Then we have tail, head, tail, tail, head, tail. Then we have tail, tail, head, tail, tail, head. And then we have tail, tail, tail. So we have tail, tail, tail. So these are all the set of possible outcomes when a fair coin is tossed 3 times using the tree diagram. So using the table to write down all the set of possible outcomes when a coin is tossed 3 times, we are going to use this column to represent all the set of possible outcomes when a coin is tossed twice. And then we are going to use this rule to represent all the set of possible outcomes when a coin is tossed once. So when a coin is tossed twice, the set of possible outcomes are head, 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 tail, tail, head, tail, tail. So we are going to write these outcomes in this column. So we have head, 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 tail, tail, head, and then what? Tail, tail. And then we are going to use this to represent head and then tail. So once we have this, we pair these possible outcomes one after the other. So this and that will give us head, head, head. This and that will give us head, head, tail. Head, tail, and then head will give us head, tail, head. And then this and that will give us head, tail, tail. Tail, head, and then head will give us tail, head, head. This and that will give us tail, head, tail. This and that will give us tail, tail, head. And then this and that will give us what? Tail, tail, tail. So the set of possible outcomes for a coin being tossed 3 times is all those outcomes within this arena. So we have head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and then tail, tail, tail. As easy as that. So as I said earlier on, we can use the table or the tree diagram to write all the set of possible outcomes for a compound experiment. This brings us to the end of today's lesson. See you tomorrow. Bye bye.